Now, my dear students, I will discuss about the Biot Savart Law. Biot and Savart conducted experiments on the force exerted by an electric current on a nearby magnet. They arrived at a mathematical expression that gives the magnetic field at some point in space due to a current. Statement. Excuse me. Magnetic field B along a vertical current carrying conductor or wire in a closed surface is directly proportional to the current I and inversely proportional to the perpendicular distance from the point of conductor or wire. That means that totally depends on the vertical current carrying conductor and in a closed surface directly proportional to the current and inversely proportional to the perpendicular distance from the point of conductor wire. If it is a wire, infinitesimal wire, in some statements we have studied before. If it's a wire, just take some dl, very smaller distance, and there is a point that you have to calculate the magnetic field, how much magnetic field that the point feels. Okay, so there is a vertical current carrying conductor in a closed surface is directly proportional to the current and inversely proportional to the distance, that is the distance between the point that we have taken here, that is the magnetic field. Because if it is electric field, the magnetic field will be the perpendicular to it, and as it is a cylindrical component, or you can say that it's in a wire, so the field will be circulatorily. And if we take a certain del B or a dB, that means the magnetic flux on it in the interim path, and take the point, a certain point, the distance between the smaller distance and the magnetic field point will be R, and that is going to be the inversely proportional, and the current will be the current that flows here, that will be proportional to it. That will be proportional to it. Okay, now the proof. So consider a current carrying conductor in a closed surface. Mathematically you can write the Biot Savart law. The magnetic field is proportional to I and anti-proportional to R, I divided by R. If you just make it equal to it, take a proportionality constant K, and its value depends on nature of closed surface where conductor is situated. Conductor will be, the spelling is wrong here, conductor is situated. So K is equal to mu naught divided by twice pi. That is experimented, and we get this value, that the proportional constant value is mu naught divided by twice pi. Mu naught is the permeability of in free space. That is the mu naught, the permeability of free space, that has been 4 pi 10 to the power minus 7 Henry per meter. You can take H as Henry like this. This flux, you can take Henry like this, and K is equal to 2 into 10 to the power minus 7 Henry per meter. So after calculating this, you can get B is equal to mu naught I divided by twice by R. Okay, mu naught I divided by twice by R in a certain cylindrical component, that is a wire. So did now the direction of magnetic field will be that if it is electric current, the magnetic field will be circular like this alongside the wire. Now that is the main part of the statement of Biot Savart law. And we have studied Ampere's law in past. Thank you very much for being with me.